Surface tensions. A surface tension is basically a property of liquid. The liquid surface behaves like a stretched elastic membrane which has a natural tendency to contract and tends to have a minimum surface area. This property of liquid is called surface tensions. In intermolecular forces, cohesive force, the force acting between the molecules of one type of molecules of same substance is called cohesive force. Now, adhesive force, the force acting between different type of molecules or molecules of different substance is called adhesive force. Intermolecular forces are different from the gravitational forces and do not obey the inverse square law. The distance up to which these forces effective is called molecular range. This distance is nearly 10 to 9 meter. Within this limit, this increases very rapidly as the distance decreases. Molecular range depends on the nature of the substance. Properties of surface tensions. Surface tensions is a scalar quantity. It acts tangential to liquid surface. Surface tensions is always produced due to cohesive force. More is the cohesive force, more is the surface tensions. When the surface area of liquid is increased, molecules from the interior of the liquid rise to the surface, where this work is done against the downward cohesive force. Dependency of surface tensions on the cohesive force. Those factors which increases the cohesive force between molecules increases the surface tensions, and those which decrease the cohesively force between the molecules decrease the surface tensions. On on impurities on impurities, if the impurities is completely soluble, then on mixing it in the liquid, its surface tensions increases. For example, on dissolving the ionic salts in a small quantity in a liquid, its surface tensions increases. If the impurity is partially soluble in a liquid, then its surface tension decreases because the adhesive force between insoluble impurity molecules and liquids molecules decreases cohesive force effectively. For example, on mixing detergent in water, its surface tensions decreases. Surface tensions of water is more than alcohol plus water mixture. On temperature, on increasing temperature, surface tensions decreases at critical temperature and boiling point it becomes zero. Surface tensions of water is maximum at 4 degrees Celsius. On contaminations, the dust particles or lubricating materials on the liquid surface decreases its surface tensions. On electrification, the surface tensions of liquid decreases due to electrifications because a force starts acting due to it in the outward directions normal to the free surface of liquid. Definitions of surface tensions. The force acting per unit length of an imaginary line drawn on the free liquid surface at right angles to the line and in the plane of liquid surface is defined as the surface tensions. For floating needle, 2Tl sin theta is equal to mg. Required excess force for lift. Wire F axis is equal to 2Tl hollow disk f access is equal to 2 pi t in bracket r1 plus r2. For ring, f access is equal to 4 pi rt. Circular disk, f access is equal to 2 pi rt. A square frame, f access is equal to 8 at. A square plate, f access is equal to 4 at. Work, surface energy is equal to T del A. Liquid drop, W is equal to 4 pi r square T. Soap bubble, W is equal to 8 pi r square T. A splitting of bigger drop into a smaller drop, R is equal to N to power 1 upon 3 R. Work done is equal to change in surface energy 4 pi R cube T in bracket 1 upon R minus 1 upon capital R is equal to 4 pi R capital R square plus capital R square T in bracket N 1 upon 3 minus 1. Excess pressure P excess is equal to P in minus P out. In liquid drop, P excess is equal to 2T upon R. In soap bubble, P excess is equal to 4T upon R.